All right, welcome back. And in this video, I'm going to go through the practice nomenclature worksheets that are available on Canvas. So let's get started on this first page. We are going to write the correctly spelled names for the following compounds. So list of formulas followed by the names. You might want to have started this. If not, I will get you started, but you might want to pause the video and go through a few at a time, see how you can do. So, okay, we're going to work on this, and as we go through, we're going to pay attention to a few things. We want to make sure we're writing down, following the right rules. So we've got rules for ionic compounds. We also have rules for molecular compounds. And we have to make sure that we're writing the correct format for those specific types of rules. So when we're dealing with the first one here, we notice we have a metal and a non-metal. So we're going to write this name as the name of the metal, followed by the non-metal as an ionic compound. So metal, non-metal halide. So we have lithium, followed by chloride. Right? I don't need to specify there's only one lithium or only one chlorine because it's an ionic compound. Let's go to the next example. We have another metal, non-metal. So this is also an ionic compound. So these are ionic, another ionic. Okay, so calcium, and then we have bromine, so we'll change that into bromide. Now again, I don't need to specify that there are 2 bromine atoms and 1 calcium because that is built into the formula. There's actually only one possible formula that you can write down for calcium and bromide together, and that's the one shown, because both of these have fixed charges. So we only need to write down those words for it, because there's only one possible formula that can come from those series of words. All right, let's go to the next example. So here we have Sr, which is strontium. And strontium is a fixed charge metal. You will find it in group 2. So it has a +2 charge. And so this is a fixed charge metal, so we don't need any parentheses here explaining what the charge is. And then we have oxygen, and we're going to turn that into oxide. Okay, the next example, we have potassium and sulfur. So we can write down the name of the metal, potassium, followed by the name of the nonmetal, and that's sulfide. Okay, so here on our next example, we have Be, which is beryllium, and then CO3. That's the first example of one where we see a polyatomic ion in the formula. And this particular polyatomic ion is called carbonate. So we would write down the name as beryllium carbonate. I'll just jot down here in the margin the carbonate ion, which is CO3 with a 2 negative charge. That's called carbonate. All right, so if we look at the next example, we have a sulfur and 3 oxygen atoms together in the formula. These are both nonmetals, and for that reason, this is the first example of a formula that we've seen that is classified not as an ionic compound, but as a molecular compound. So the formula for this, or the name I should say, should be written down as the name of the first element, followed by the name of the second element with an ID ending. However, we have to use the Latin prefixes to designate that there are 3 oxygen atoms. So the correct name is sulfur trioxide. Just a quick reminder, this is not sulfite. Sulfite would have the formula SO3, but with a 2 negative charge. All right, let's go to the next example. All right, so looking at the next example, we have Al sub 2, O sub 3. This is aluminum with oxygen, and so therefore is ionic. Aluminum is one of our fixed charge metals. It has a +3 charge. And we would write the name for this as the name of the metal, which is aluminum, followed by the name of the nonmetal with an IDE ending. And so we say aluminum oxide. We don't need any parentheses or any Latin prefixes for ionic compounds. All right, let's take a look at the next one. Okay, so here we see another polyatomic ion that I have in green. That is C2H3O2, and this is known as acetate, and it has a -1 charge. So when we write down the name for this, we say the name of the metal, which is sodium, followed by the word acetate. All right, so once we have sodium acetate there, let's look at a few more examples. I might go through a few of these a little quicker. So here we have Br, which is bromine, and fluorine. Those are both non-metals, so this is a molecular compound. And we would name this by saying bromine trifluoride to designate the 3 fluorine atoms. Go to the next one with lithium and nitrogen. We see lithium is a fixed charge metal and then nitrogen is a nonmetal. So this is an example of a standard ionic compound. So we'd say lithium nitride. Then we get silver, and we have the polyatomic SO3, which is sulfite. So this is silver sulfite. Sulfite is 2 negative charge. Then we go to the next example. We see another ionic with a polyatomic ion in it. We have hydrogen carbonate, or bicarbonate for short. This is potassium is the metal. So the name for this would be potassium and then bicarbonate or potassium hydrogen carbonate. Both are acceptable. Okay, so in our next example, we have barium, and we have a polyatomic ion, which is NO3. There are two of them. Barium is a fixed charge metal, so we just write barium, and then this is followed by the polyatomic anion, nitrate, so barium nitrate. Another similar example here, we have aluminum with a +3 and a sulfate, which is a polyatomic ion with 1 sulfur and 4 oxygen atoms and a 2 negative charge. So this is aluminum sulfate. Okay, our next example here is the first time we've encountered something that has a common name. This is called ammonia. There are a number of molecules, molecular compounds that have common names, and I want you to make sure to know those names. So there are some that are fairly obvious, like for example, water. We don't call water dihydrogen monoxide, we actually just say water. And this is the preferred name for these compounds, the common name. Here are a few more. We have ammonia, which has the formula NH3. We also have hydrogen peroxide, which is given that name because it has the peroxide in it with hydrogen. So it's H2O2. Finally, we have hydrogen sulfide, which is the formula H2S. Okay, so these are all common names that deviate from the official or the systematic name. Now we're going to run into our first example of a metal that has a variable charge where we also have a polyatomic ion. So we have cadmium here. This is a variably charged metal. So when we write the name, we have to put in parentheses the charge on the metal. Now, the polyatomic ion we have here is OH, or hydroxide. Hydroxide has a -1 charge, and it shows in the formula there are 2 of them. So when we're trying to determine the charge on cadmium, we have to add up the 2 negative charges. So we have 2 negative. That means the cadmium has a 2+. So we put in parentheses a Roman numeral 2 for cadmium 2 hydroxide. All right, the next example, just another polyatomic. This is ammonium, and then we have phosphate. So this is ammonium phosphate. Okay, our next example has magnesium and a polyatomic ion, which is called cyanide. We have magnesium cyanide. Okay, in the next example, we have a molecular compound, 2 nonmetals, and we have to use the correct Latin prefixes. So the Latin prefix for 4 is tetra, so we write tetra, and then the word phosphorus. And then we have 10 oxygens, so it's decoxide. You could also write decoxide or decaoxide. I'm not really partial to either. The next example is another ionic compound called the zinc acetate, and then we have potassium dihydrogen phosphate, rather. So we have the H2PO4. This is called dihydrogen phosphate, not hydrogen phosphate. So the correct word name for this is potassium dihydrogen phosphate. Here are the formulas for the polyatomic ions, which again, you can look these up. Phosphate is PO4 3-, biphosphate is HPO4 2-, and then the diphosphate is H2PO4 1-. So it's the bi and then the di. All right, let's go to the last example here, which is chromium and 3 chlorine atoms. This chromium is a variably charged metal, so we use parentheses to designate its charge. And if you go through the balance sheet, you will see each chloride is 1 negative, and we have 3 of those, so that adds up to 3 negative, and then that must mean we're balanced by 3 positive charges on the chromium. All right, so that's the first page of these. Let's go to the next page and do a few more examples. Okay, so on this page we have a number of names for formulas, and we need to come up with the formulas for those names. So in each case, we're going to need to make sure we have the right number of cations and the right number of anions so that we get a total charge of 0 for all of these. If we're dealing with molecular compounds, the name will be just given to us by the formula, the formula by the name. It will tell us how many of each atom are present. We don't need to worry about charges for molecular compounds. So let's go ahead and do the first few of them. So we are going to use the same process when we come up with the formulas for each of these, which I showed in the lesson on nomenclature, which I call the balance sheet method. So when we have a word like barium chloride in name, we have to come up with a balanced formula, meaning balanced by charge. So we know that barium is a +2 metal. You can find that on group 2 of the periodic table. We also know that chlorine is a -1 when it's ionized. To come up with the right formula for this, I need to make sure that my charges go to 0. And if barium is +2 and chloride is -1, that means I need 2 chlorides to balance the charge out. So I showed my work over here in the margin. We're going to follow that same process for all of these. So let's go through. I'm going to go kind of through some of them a little quicker than others. But in each case, if you're wondering how I arrived at that formula, make a little balance sheet and see if you can get the charges to add up to 0 following sort of the formula that I show. Okay, so in this next example, we have potassium carbonate. So we know we have potassium and we know we have carbonate, but let's look at the formula real quick. Potassium has a +1 charge and carbonate has a 2 negative charge. For this to balance out, we need to have 2 potassium atoms with a +1 charge each to add up to 2 plus. Therefore, we can use that to balance the 2 negative charges coming from carbonate. So it's 2 plus and 2 negative equals 0. So we need to make sure we have that subscript 2 next to the potassium there. All right, let's look at the next few. Now, lithium hydroxide is pretty straightforward as long as we know the hydroxide is an OH. So the formula would just be 1 lithium and 1 hydroxide because each has a +1 or a -1 charge. So they balance out in a 1-to-1 ratio. Now, looking at the next example for magnesium nitrite, we have to recognize that nitrite is a polyatomic ion with the formula NO2 and a 1 negative charge. We also have to realize that magnesium is a group 2 metal, so it has a +2 charge. To get this to balance out, we need to balance the 2 plus with 2 negative charges. So that means we need to have 2 instances of the nitrite. So I'm showing that in the balance table here. If we have 2 of those, we add up to 2 negative charges, and that will balance out our 2 positive charges, and the formula is Mg with 2 nitrites, and we represent that with parentheses and a subscript 2. Okay, so a few more examples here. We have zinc hydrogen phosphate. Zinc is a fixed charge metal with a +2 charge, and hydrogen phosphate is HPO4 with a 2 negative charge. So we would write the formula ZnHPO4, and we just need 1 of each. Iron 2 sulfide, that is iron with a +2 charge, and a sulfide. Sulfide is a 2 negative, so the formula would just be 1 of each of these. Iron 3 cyanide is iron with a 3 plus charge, and cyanide is a Cn with a -1 charge, so we need 3 cyanides for every 1 iron. So we would put those in parentheses, Cn with a subscript 3. Chromium 3 acetate is chromium with a 3 plus charge, and acetate. Acetate is C2H3O2 with a -1 charge. So we need to have 3 of these acetates for every 1 chromium if chromium is in the 3 plus state. So the formula would just be Cr with C2H3O2. We put that in parentheses and then subscript it with a 3 to make sure we have the right balance of charge. Carbon monoxide, that is a molecular formula with the mono telling us there's only 1 oxygen. So we have 1 carbon and 1 oxygen. Sulfur dioxide, on the other hand, has the di prefix in it. So there are 2 oxygen atoms in addition to the sulfur. Let's go on. Okay, so in our next example, we have another molecular compound with the name dinitrogen monoxide. That tells us we have 2 nitrogen atoms and 1 oxygen atom. So it's N2 and then just 1 O. so N2O. Now we have ammonia again. That is, again, a common name for the formula NH3. Then we have mercury 2 oxide. This is an ionic compound with a variably charged metal, mercury. It tells us we have a +2 charge on mercury, and because oxide is a 2 negative, we need to have one oxide and one of the mercury atoms, so HgO. Now we have calcium sulfite. Calcium is a group 2 metal with a +2 charge, and sulfite is a 2 negative polyatomic ion, so we need one of each. Next we get to manganese 2 phosphate. Manganese is a variably charged metal, and it indicates we have a +2 cation. Phosphate is a polyatomic ion with the formula PO4 with a 3 negative charge. So we need to put these in the right combination. The least common multiple of +2 and 3 negative is simply 6. So if we had 3 manganese, that would give us 6 positive charges. And if we had 2 phosphates, that would give us 3 negative charges. So the correct formula for this would incorporate 3 manganese and 2 phosphate. So for our next example, we have the word ammonium bisulfite. Bisulfite is hydrogen with a sulfite attached, and that's HSO3 with a 1 negative charge, and then we neutralize that with 1 ammonium. So if we have one of each of these, we would have a 0 charge. Okay, our next example here, we have chromium with a 2 plus and an iodide, which is in the group 7 or halogens, so that has a -1. To make this charge balanced, we need to have 2 of the iodines with 1 of the chromium 2 pluses. Okay, so we would put Cri sub 2. We don't want to put that iodine in parentheses. I see sometimes some people making that mistake. Remember, only polyatomic ions go inside of the parentheses. All right, the next we have aluminum hydroxide. Aluminum is a +3 fixed charge metal. Hydroxide is a -1 polyatomic ion, so we need 3 hydroxides for every 1 aluminum. Lead 4 oxide is lead with a +4 charge and oxide with a 2 negative charge. So the formula would be lead, which is Pb, and then O when we need 2 of those, so O sub 2. Our last one here is sulfur hexafluoride. That's a molecular compound. We have 1 sulfur and 6 fluoride. So we write S and F, and then we have the 6 subscript next to the fluorine, so SF6. All right, so that's the worksheet. If you got those right, great job. If you have any questions about any specific examples, or you need more of an explanation or anything like that, like maybe you think you want to talk about one of these as having maybe a different formula or a different name, please let me know. If send me an email, stop in during office hours if you needed extra help or anything like that. So thanks for watching. I will see you soon.